I was going to say, now I'm going to tell you what's really going to happen. So, as Morten mentioned, my focus is really on the core development team, the C programmers, whereas Morten is looking after more of the tools programmers and the infrastructure around the product. So this is really a view from the core development team working on the interpreter. I'd like to do a bit of a recap of the major features that were in version 15, so to remind those of you who've already upgraded what's in there, and hopefully tempt those of you who haven't upgraded yet. And then talk a little bit about what's going on for version 16, coming out next year. So we're sort of well underway in the planning and development of that. I'll tell you what's going on. It's by no means all definite at this stage, but I'll tell you our plans, and then a little bit about some other developments that aren't specifically tied to interpreter releases. So, version 15, major features. Performance, native file functions, APL source in Unicode text files, RIDE 3, hashed arrays, and a few minor features. I'll talk through some of these. So, performance. One of the big things about version 15 is it has the biggest increase in performance of any release that we've ever measured. And the fact that we've been able to measure it is probably the most impressive thing there. We now have these PQA, performance QA suites that we run every night so we can track the performance of our releases. It allows us to produce nice blue graphs to show off when things are getting faster, but more importantly than that, it allows us to have a fairly high degree of confidence that we haven't slowed anything down as we've been changing the code, because people don't like nasty surprises. The performance in version 15 came from two different things. One was people like Roger working on an incredibly long list of specific speedups to particular primitives, idioms, operators. So, for example, this is a small selection of the specific things that went into version 15. The whole dyadic iota set functions family had significant speed-ups for small integer and character data in particular. There was a bunch of optimizations specifically for doing reductions on a partition of a vector. So if you want to partition a vector and then take the length of each partition, or the max or the min or the sum of each partition, those are recognized as special cases and optimized. There have been a whole bunch more special cases for the rank and key operator. Formatting of both floating point data and small integers has been significantly speeded up. There's been a lot of work on the general case of inner product and on some specific Boolean reductions. There was a nice new algorithm for doing windowed reductions where you're looking for the sliding windowed maximum or minimum. Grade up and grade down have been optimized on permutations, and the list goes on and on. In version 15, there was an especially long list of specific optimizations. And the other thing that contributed to that nice blue graph that we keep showing you is that we upgraded the C compilers that we used on all of our major platforms, and in some cases, particularly on Windows, because we were using a very old version to start with, we got a very nice speed up in upgrading the C compiler. One of the major portability improvements in version 15 is that we introduced a load of new native file functions. So the idea of these is to help abstract the details of your file system regardless of what operating system you're running on. So where previously you might have had to use something like quad.sh to try and get a list of files in the current directory, and that would work completely differently on Windows, Linux, and the Mac. Now we've introduced a set of functions like quad.ninfo, which will allow you to do that in a platform-independent way, get a list of files. Make dir creates folders or directories, again, in a platform-independent way, and there are a few other utilities. We may be introducing more in future. Perhaps, where's Richard? Did you discuss that in the bar area last night?
We did have a discussion, but we didn't discuss any new ones.
Okay, well. Well, anyway, this is a starting point. We are open to the idea of introducing new native file functions in future to try and kind of complete the set. And also on this page, nget and nput are similar in some ways to the native file functions for reading and writing to files, but they're designed to take an entire file's worth of Unicode text, load the whole thing, do the conversions depending on what how the file is encoded, so they know about things like UTF-8 and UTF-16, and they know about different line ending characters. And part of the reason for introducing those is that they tie into another big new feature in version 15, which is improved support for keeping your source code in text files. This is part of a general drive to try and encourage people to use scripts for maintaining their APL code, as opposed to storing your APL code in a workspace and just keeping copies of the workspace. In particular, this makes it using scripts makes it very easy to take advantage of standard version control systems, and if you're open sourcing and doing your development on GitHub and things like that, it's virtually impossible to do that with workspaces. You need to be working with text files. So in order to encourage that and make it work more smoothly, the interpreter now supports, by default, being able to edit a text file on disk that contains the source of your function or namespace, and the interpreter will remember the association between that function and the file where it came from on disk. So when you go to edit your function, you get the option of also updating the source file on disk at the same time. In addition, the editor knows about how to highlight a few different kinds of content, so you can use the Dyalog editor for editing JSON and XML, and it will recognize them. So last.
In your previous sentence, you seem to be using the words function and script.
Yes, we are. I believe the sort of... Sorry, yeah. Phil was asking whether we are supporting a mode of working where each source file contains a single function, as opposed to a source file containing a whole scripted namespace. And the answer is yes. We are now supporting source files that contain a single function or a whole scripted namespace, and possibly more than one function in a file. Yes? Yep. And as part of this, those of you who've used Salt may be familiar with magic comments you could put in your salted scripts to say that a particular scripted thing, like a namespace, requires another one. So if you are writing one class as a scripted namespace, you might say it requires the base class script. And this has also been promoted to a first-class feature in the interpreter, so you can declare dependencies where, in order to run the code in this script, you need to also have loaded this other script. Morten mentioned RIDE 3, which had reached a certain level of maturity with the release of version 15, so I won't repeat what he said. More core features that went into the interpreter. This is really a performance thing. It's a way of hashing an array. I use the term hashing very loosely. It's a way of saying that I'm going to be doing searches on this array, so I'd like you to please construct a hash table or a lookup table or something that will help the interpreter to do fast searches on the array. For quite a long time, we've had a slightly clunky mechanism where you could bind an array as the left argument of dyadic iota, or similar cases for the other set functions. And then if you reuse that derived function, it would actually keep a hash table and reuse the hash table. The new mechanism where you explicitly say, I want this array to be hashed, is more powerful, because once you've hashed an array, you can use it on any set function you like, You don't have to go around constructing different derived functions for different set functions. And most importantly, the hash table will get updated when you modify the hashed array in a very restricted, specific set of circumstances. In particular, this is designed for looking up on long vectors, really. So if you append to that vector using the append idioms, comma gets or comma bar gets, to add a few new entries on the end, then the hash table will get updated in place to reflect that. You won't have to completely rebuild your hash table from scratch. And similarly, there's a new idiom called chop, which is designed to cut off the last few items of long vector. And again, the hash table or lookup table will get updated to reflect that. So really, that's designed for looking up in large data sets, which you might occasionally add a few records to the end of. If you've got a database of all your user IDs or something, and occasionally you have a new user register, you can append to that table without having to take a big hit while you rehash all the data. Skip that. My favorite little languagey feature in version 15 is we fixed catenate reduction. This is something that I remember catching me out in my first year of writing APL at Dyalog. It seemed to me incredibly difficult to catenate a bunch of strings together and still have it work if you had a list of 0 strings. You know, at this point, you're trying to do a catenate reduction of no strings at all. You used to get a domain error. Now you get what I think is just obviously the correct answer. Hopefully that should avoid people writing ugly workarounds like always sticking an extra blank string on the front of their list. And this is really a long overdue implementation of an idea that comes from certainly APL2 and probably further back than that, of having identity functions. So the catenate reduction of an empty list actually examines the prototype of the empty list that you're catenating and does the appropriate thing. There's a function that tells you, based on the prototype of the empty thing, what the result ought to be. You don't really need to know that level of detail because I think 99% of the cases will just be this. You want to catenate a bunch of strings, you want the empty string if there aren't any strings in that list. There's also some work on the bytecode compiler in version 15. Those of you who were in the workshop yesterday will have seen most of this. Probably the nicest feature out of that lot is in the Dyalog function editor. There's a little option on the view menu that you may not have seen, which says show compiler errors in the editor. So if you're writing new code and you want to be sure that the bytecode compiler can handle what you're typing, you can turn this on and you'll get a live display down the side of your function with little red dots or red bars telling you when the compiler has seen something that it is unable to compile. You can hover over the red bar and it will pop up a little pop-up telling you what it objected to. So that's version 15. It was released at the end of June. It's free for non-commercial use. And it's got a new icon. So, version 16. This is where things get slightly more speculative. Some of this is stuff that we've already implemented. Some of it is stuff that we definitely plan to do. Some of it is slightly more up in the air, and I'll try and let you know as we go through how definite these things are. First thing is performance. I'm not going to say anything about that now because there's a whole session on this. The session tomorrow that Roger and I are doing is about performance in version 15 and in version 16. So come and see that. Version 16, Morten mentioned that as a rule we're trying to slow down the pace of innovation a bit, but that's a difficult thing to do. In version 16, we are planning to introduce a couple of new squiggles and a few new primitives. These, as I say, are various stages of the process. Where and enclose are simple are pretty much definite. At is reasonably certain, and these ones down here are less certain. And your feedback is important to us. We'll be presenting more on these, I think, tomorrow. And based on user feedback, we may tweak the design of these things. We may decide to do them or not to do them based on what you tell us. So we're interested in what the users think here. Speaking of the pace of innovation, the things that we're most confident about introducing are the simplest features. So, for example, there's a primitive function where, which you could previously write as an idiom, something like omega reduce iota rho omega. It's now graduated to a primitive, really by popular demand. We've had extremely strong support from the users for this kind of thing. You give it a Boolean vector, and it tells you where the ones are in that vector as a primitive function. There's precedent for this in other APLs like NAS 2000, and some of them have extended it in various ways so that the argument doesn't need to be Boolean or can be higher ranked. We're trying to be a little bit conservative with it. At the moment, the idea is it does have to be a Boolean argument. I think you can give it a higher ranked argument, in which case it will give you back tuples of the indices of the ones in that array. And enclose are simple. There's another very simple idea. This, again, is due to popular demand, and in particular, I should thank Adam for beating us all over the head until we agreed that it was a good idea. This, I think, is mostly of interest to application programmers. Enclose if simple does what it says on the tin. If you give it an argument, if that argument is a simple array, i.e. a simple scalar or typically a simple vector, it will enclose it. Why would you want to do this? Well, it's really for functions which might be given a bunch of strings as arguments, 1, 2, 3, 4, but in some cases, you might want to give them just a single string. And it's a pain for the application programmer to cope with that case, because that looks like a vector of 3 things. If you apply enclose if simple to your argument as the first step, if it's given a simple string, it will enclose it, and at that point, you're pretty much guaranteed that your argument is depth 2, or it was a simple scalar, in which case I think you'd be okay anyway. Kai Jaeger. Kai said, what if the right argument is a scalar? My answer to that is, it does what it says on the tin. If it is a simple scalar, it will apply enclose to it, and you will still have a simple scalar. So it's not true to say it will guarantee that your argument has depth 2 or greater, but it is true to say that you won't be confused by the case of getting a single string.
And this is strictly enclosed. You get a scalar result from your second example.
Yeah, Phil was asking, is it really just enclosing the argument? And the answer is yes, it really is enclosing it. In the second case, the result of applying enclose if simple to that string is an enclosure. It's not a length 1 vector, for example. It's a scalar, a nested scalar. So these two, we believe there's pretty much universal support for, and we're planning to implement. Getting on to the slightly more contentious ones, John Scholes has been working on Adam. Yeah, okay. Adam has just reminded me that we are planning to use the dyad. So this glyph here, this left two underbar, is a new glyph to go on the keyboard. Adam's just reminding me we're also planning to use the dyadic case of that glyph to represent APL2 partition. So the reason for that is currently you have to switch, if you want to use the APL2 version of partition, you have to switch your quad ML to 3. We're trying to promote the fact that quad ML1 is the one true value of quad ML. So we're removing possibly the only case where most people ever need to localize QuadML and change it, or the only common case. So the plan is that this glyph dyadically will give you APL2 partition regardless of your QuadML. The reason for that is it lets you stay in QuadML1. Carlo.
I understand the commercial reason to do that, but all the way to do partition we have in APL, APL2, different seems more interesting than.
You are correct. I can't argue with that. Carlo is saying that both the APL2 partition and the Dyalog partition don't have any way of specifying that you want some of your partitions to be empty. Yes. I can't argue with that.
I'm curious about this. I love the glyphs, but isn't there a cost to adding glyphs? Don't you have to talk to the International Typesetters Union or something?
Isn't there a cost to adding glyphs? There is a cost, but it's not great. They're already in Unicode, so we're sorted there. Yes, definitely. They're already in Unicode. The only cost that we need to worry about is making sure that they're available on all the keyboards and IMEs and input mechanisms that we support. But in these cases, I think we're pretty comfortable with that. Right. At is a triadic merge operation that John Scholes has been developing, where you want to say, please give me this array, but, by the way, modify or replace these particular items with these new values. And that, and a couple of other things, are going to be presented this afternoon by John Scholes and Roger Huey. So there's the at operator, there's, I think we're calling it a tile operator, which is one particular case of Sharp APL's cut operator, and there's also a proposed, another primitive, which would probably be a dyadic use of iota underbar, which is similar to the existing index of, but allows you to look up values in a bunch of intervals. Rather than looking for exact matches, the left argument will sort of partition the number line into a section of intervals, and it will do a kind of lookup of which values fall into which partitions. Anyway, for all the details on that, 2:45 this afternoon, John Scholes and Roger Huey. Morten mentioned we're planning to improve JSON and CSV support. Quad JSON we already have I-beams for, so it's really just a case of making sure they're rock solid and promoting them to system functions. Quad CSV, we're sort of in the process of designing that. It's, in some ways, it's simpler than JSON because the format is typically simpler, but it's also more complicated because JSON is a standard, CSV is, it's a mess. There are standards, there's lots of standards, people do their own things. So we're trying to feel our way through that, work out what features people need, what modes of operation it should support. If you're interested in that, please come and talk to us and let us know what you'd like to see in that. And, right, some more language features. One I feel obliged to air publicly. We're planning to change the way that error guards work in defins. Currently, error guards in defins have lexical scope, which means that if you program with nested defins and one of your inner defins throws an error, it can be caught by an outer defin. But if you have completely separate capsules, one defin that sets up an error guard and then calls a different one over here, and the called defin throws an error, currently it will not be caught by its caller because it's in a different capsule. We've thought for a while that this is wrong, and all the sort of significant users of defins that we've spoken to agree that this is clearly wrong and that errors from defins ought to propagate up the call stack. So you are hereby warned that we're going to try to change that. If this worries you, come and talk to us, or if you think it might affect you, or if you're a heavy user of defins and you like the idea, then please come and tell us. Right, I'm going to skip on a bit. A brief mention, we're hoping, no promises, we're hoping to try and get rid of the existing Patchwork Space method of updating APL in favour of more modern standard things. Yes, hands up if you like the Patchwork Space. Okay. Well, it's not a done deal, but we are hoping to try and obsolete that in favour of doing it the way everyone else does it, using MSI update packages on Windows and equivalent things on Linux. Right, on to things that are not directly tied to the interpreter. We've been running this codefens, well, Aaron Zhu has been running, where is Aaron? Running this codefens project for a few years now. I'd still classify as experimental, but this year we've been working with a couple of key customers who are interested in trying to take advantage of this. So Aaron's been working closely with them to try and make sure that the capabilities of the compiler match what people are actually trying to use it for, get some real application code and get some real results from it. Aaron's going to be talking about this 9 a.m. tomorrow, first thing. Come and see him after breakfast. And more generally, as a sort of slightly longer term strategy, I think Dyalog needs to think more seriously about how we let you take advantage of the GPUs. Aaron's work is great. It's possibly not the only thing we should be doing, though. For example, you could imagine that the core Dyalog interpreter, if we work out specific algorithms or specific cases of primitives that can really benefit from doing something on a GPU, that the interpreter could offload some of that work for you, or that you could ask the interpreter to do a certain particular calculation on the GPU. I think the major benefit of Aaron's work from Dyalog's point of view is that it's helping us to build expertise on the kind of algorithms and techniques that you need to extract the best performance from a GPU for doing typical array programming operations. So we're still kind of working on that whole area. We need to build more expertise within the company and working with Aaron to try and work out what the sweet spot for APL is. Aaron's work represents one model where you write a whole bunch of code in a slightly different dialect and compile it separately. You could imagine at the other extreme, the interpreter does everything for you and just magically decides when to use the GPU to speed up your program. I think we need to find some kind of compromise in the middle, and we don't know what that will be yet. I think I'm pretty much out of time, so I will say briefly that we've got an interface to R. We would like to have lightweight interfaces to a bunch of other scripting languages. When I say lightweight, I just mean that the kind of object integration model won't work as seamlessly as it does for things like .NET. We'd like to have something simple that allows you to call a bit of code in Python, pass the data, maybe down a socket or something, and get the results back. But we'd like to make it much easier for people to interoperate with these other languages in a simple-minded way.
Jay, what about both directions, about calling APL from one piece?
Jim asked if we're talking about calling in both directions, so calling from these languages back into APL. Yeah, certainly that would be great. We haven't got as far as thinking about how that would work, but yeah, definitely. I've talked a bit about support in the interpreter for having your source code in script files. So this is really just another way of saying we like scripting. We're encouraging as many people as possible to use scripting for their APL code. I don't know if Morten mentioned the idea of an APL project manager project. We certainly talked about it in the past, and scripting would certainly be a key part of this. Okay, let's make that one disappear too, since I've run out of time. So, CTO goals. As I've mentioned, understanding the GPUs, finding the right way for APL to take advantage of them. I don't know what that will be yet. This is a long-term goal. Interface with other scripting languages. Keep pushing the core performance. As I said, we've got to talk about performance tomorrow. And expand the core development team. We have, as Geeta and Morten mentioned, I can't announce anything yet, but we are hopeful that by the end of the year we should be able to announce something about taking on additional C programmers for the core development team. And the reason for that is really that we have certain members of the team who are aging gracefully. Some of them are winding down their hours, and we've also lost a couple of people over the last couple of years who we haven't properly replaced. So there's room in the development team, and there's certainly plenty of work to keep us all busy. And really, we need to build the next generation of core interpreter programmers at Dyalog to make sure that we can continue what we've been doing for many years to come. Thank you.